Okay, so we're already done discussing on the growth and decay, exponential growth and decay. Now let's talk about the cooling. No, this is the Newton's law of cooling sa differential equation. So, unsa na diri sa Newton's law of cooling? So we have this is ato sa sulat, no. This is the capital T is the temperature. The small letter t is the time. And then, ay nakabutang diri nga T minus Ts. So, the T is the temperature of the object. And then, the T sub S is the temperature of the surrounding. So, sige ingon ni Newton's law of cooling. Yun siya nga. The rate of change sa temperature with respect to time is directly proportional to this one, kani, to the change of cooling or the difference of the temperature sa object and then the surface area exposed. So that is T minus Ts. So again, this is we have a proportionality symbol here, then we add constant para ma-equal sila. We have this K times T minus Ts. If you notice, this is a big capital T, and therefore we can apply the variable separable. This becomes dt over T minus Ts is equal to K dt. And then we integrate both sides. So we will have ln T minus T sub S is equal to kt plus C. Again, para ma-remove ni C natural logarithmic function, we raise the whole equation into exponential. So this becomes T minus T sub S is equal to e raised to the kt times e to the c, diba? As what I mentioned you, and then ang e to the c nga constant, it's just c. So this becomes T minus Ts is equal to c e raised to the kt. So again, kaning dako nga this T, temperature of the object, temperature of the surroundings, and then the K is also the constant, T is the time in, let's say, minutes or seconds, and then C is the initial condition. So now, ato ni pangitaon unsa ni si C. So, let's have a condition. Let's say at time is equal to 0, ang temperature nato is initial temperature. So, ato na siyang substitute from this equation. Then we have T naught minus the temperature of the surroundings is equal to, so mo ni siya C e raised to the K times the time at 0. So this becomes 1. Therefore, atong C nga constant is TO minus TS. Therefore, this equation then becomes what? T minus TS is equal to initial temperature of the object minus temperature of the surroundings, E times E raised to the KT. Or, since kaning ang K nga proportionality gani na to, it is written as like a negative K, then our final, we have T minus Ts is equal to TO minus T sub S is equal to E raised to negative KT. And we can use this equation for our Newton's law of cooling.